Welcome to AC signal representation. First, let us talk about what is instantaneous value. So imagine you have a generator and then you take note or you record the voltage across that generator or machine. So you can form this kind of waveform, okay, or signal. And as you can see, you have two signals. So just to demonstrate, and the one in solid line, we call this one the V1, and then the one in a broken line, we have V2. Now, what is instantaneous value? So that instantaneous value can be represented by a sinusoid. Okay, sinusoid. So we have V of t is equal to the Vm, or the amplitude, times the sine function of the angular frequency times the time. And then the second signal, V2, can be represented by another sinusoid, so which is Vm sine Wt plus a phase angle P, which is actually just a shift from the origin. Okay, so instantaneous value, okay, in this case voltage, instantaneous voltage is represented by V of t. So meaning at any given time, so you have this value. So you just change the value of your t with whatever time you want in the diagram. Then we call Vms the amplitude of the sinusoid. In this case, we have here the peak value of your signal. Then we have the angular frequency in radian per second. This tells us how fast the cycle, okay, of the signal or sinusoid. So we can talk about this one later in the pace. And it is also called the argument of the sinusoid. And then we have the phase angle P. So phase angle is the shift of a signal from the origin or the reference. Actually, the argument of the sinusoid is the phase angle. So sorry for that error. So the argument of the sinusoid is the phase angle. So we will have a separate lesson for this. So that's it. Instantaneous value. Instantaneous value is represented by sinusoid with its following definitions.